Today we're looking at section 8.4, scientific notation. Most of us are familiar with scientific notation. People just sometimes get confused which direction to go um, when they see a positive exponent or a negative exponent. Begin on page 470 with a couple of goals. Using scientific notation to represent numbers and ultimately describing real life situations. First thing's the definition of scientific notation. It's written in the form c times 10 to the nth power, where 1 is less than or equal to c, which is less than 10. Notice right here, um, all this means numbers 1 through 10. Your number has to be between 1 and 10. And instant integer means you don't want a decimal or fraction as your exponent. Example number 1 is rewriting in decimal form. 7.29 times 10 to the 6th. Anytime you see a positive exponent like the first one, positive means it's going to be a great big number. Notice that the second one, b, is a negative exponent. That means it's going to be a really small number. That's the way I always remembered it. Positive means move the number to make it a great big number 6 times. So if you have 7.29, you're going to move that decimal 6 times to the right. 1, 2, and then you got to move it 4 more. 3, 4, 5, 6. So your decimal will wind up at that position there, and then you have to fill in all of the empty spaces with a 0 as a placeholder. So 1, 2, 3. You have to fill it in with 4 of them. Notice there's 4 zeros, and the answer is 7,290,000. Do the same thing with 4.5, except you're going to move it 7 times. Since it's a negative number, you're going to move it 7 times to the left. You're going to make it a very small number. So we're going to move it 1 time, and then 2, 3, 4, 5, 6, 7 times. Again, that's where your decimal is going to go right there. So you're going to put in zeros in each of those spaces. So you're going to wind up with the number 0.00000045. Move it left 7 times, and the top one you're moving it to the right 6 times. Your first checkpoint comes up, 2.49 times 10 to the 5th. A big number since it's positive, so you're going to move that decimal over 5 times. So if you have 2.49, you're going to move the decimal 5 times. 1, 2. You can't forget to count those. That's a mistake I see people make. They'll just put 5 zeros. You can't do that. You move it 2 places, and then 3, 4, 5 is where your decimal goes. So you wind up with 3 zeros as placeholders. So 249,000, 249,000. First answer. Your second one, notice it is a negative exponent. So you're going to be a small number this time, which means move it to the left when it's negative. So move it 1, 2, 3 times where your decimal goes and fill in your holes, 0.0096. And then the last one, you're going to move it 7 places. Notice the number you start out with is relatively big, 4.00027. But notice that number is still between 1 and 10 because it's 4.3 of those zeros as placeholders and then the 27. It's still between 1 and 10. That number falls between 1 and 10, so it follows the rule. It is a positive exponent, which means you're going to make it a big number, move it to the right 7 times. 1, 2, 3, 4, 5. Notice how many times we moved that already? 6, 7 for your 7th one, and 2 zeros go in its place. So 40,002,700. Example number 2 is rewriting in scientific notation. So this is going the other direction. Instead of having a number between 1 and 10, we need to make a number between 1 and 10. If your decimal starts out at 618, it's behind the 8, you need to make that number between 1 and 10. That's the key. So you got to move that decimal 1, you got to move it to that spot right there. Notice you can't move it in front of the 6, because if you move it in front of the 6, then the number won't be as big as 1. It has to be at least as big as 1. So we're going to make that number 6.18. And since we had to move it 2 times, you just count how many times you move it. Once, twice. And since it was a big number at first, it wasn't a 0.0000 something like that number. It's going to be a positive exponent. So 6.18 times 10 to the second. For the second one, 2.5 times 10 to the 0. Notice 2.5, see something like that. That number is already between 1 and 10. So you're not going to move the decimal at all. If you don't move the decimal at all, don't represent it with anything. Represent it with a 0, because if you leave it as 10 to the first power, then that means move the decimal one time. Like if you just did it as 2.5 times 10 to the first power, that would mean move that decimal one time, which would create 25, which is not the number that you're looking at. You're moving it no times, so to be 0 places. And then this one, notice it's a very small number, 0.00 number. You want to make that number between 1 and 10. So if you move it over, we'll move it once, twice, 3, 4, 5 times. If we did 7.245, 7.245 is a number between 1 and 10, and we moved it over 5 times. It's a very small number, so it's a negative exponent. You moved it 5 places, very small number. D is a very large number, 310 million, so it's going to be a positive exponent. You need your decimal to start out right here, 310 million. You need to move it over 3 times, 6 times, just to save yourself a little headache. 6 times right there, 7, 8 times. The number 3.1 is between 1 and 10. Again, that's key. It's got to be between 1 and 10. But 3.1 is between 1 and 10, and you moved it over 8 times. Since it's a great big number, it is a positive exponent. Your checkpoint for this one, notice we have a very small number. We need to make a number between 1 and 10. So we need to move it over once, twice, 3 times to make the number 6, or 6.0. 6 times 10, and I'll always use an X in this case, otherwise it looks like a bunch of decimals. 6.0 times 10, and we moved it over 3 times, and it is a very small number, 0.006. It's not a very large number, so it'll be to the negative third power. Make that change if you put positive. 6.0, or just simply 6 times 10 to the negative third. Number 5 is a great big number. We still need a number between 1 and 10. So our decimal starts here. We need to move it over 3 times, 6 times. If we move it to here to the 9th time, notice we're going to get the number 800.2. We can't do that. We have to keep going. So that's 9, 10, 11 times. Now we have the number 8.002. You can't leave that off. People want to leave that 0.002 point off. That is a significant value, that 0.002. But notice that number 8.002 is between 1 and 10. That's what we were trying to get. So it's 8.002 times 10, and then it was a great big number. We moved in our number again, 3, 6, 9, 10, 11 times. So times 10 to the 11th power. 8.002 times 10 to the 11th. Number 6 is a very small number. Find out how many times you have to move the decimal. You move it once, twice, 3, 4, 5. You move it 6 times because you want to get a number 3.7 times 10. Notice the number 3.7, when you check that number, is between 1 and 10. Again, that's the key. It's got to be between 1 and 10. So 3.7 times 10, and then how many times do we move it again? 1, 2, 3, 4, 5. We moved it 6 times, and it is a very small number, so to the negative 6 power. And example number 3 has 3 separate problems. Notice this is going back to using multiplying and dividing the same bases from from Monday and then from last week. 6.0 times 10 to the third times 2.4 times 10 to the fifth. So written just like that. Notice times 10 to the third and times 10 to the fifth are the same bases. So when you're multiplying the same bases, you could add them up. Notice this is the associative property. I always show the associative property like this. Remember, 1 times 2 times 3 gives you the number 6. So does 2 times 3 times 1. So does 1 times 3 times 2. The order of multiplying things doesn't matter. So if you can just multiply straight across, you can, instead of, you can multiply the same bases, 6.0 and 2.4, and you get the number 14.4. Then what you'll have is 10 to the third times 10 to the fifth, which is 3 plus 5. 10 to the third plus 5. So it leaves you with 14.4 times 10. That's where we get to the 8th power. And when we move our decimal over, notice the number is 14.4. This number right here is not acceptable because it's not between 1 and 10. You need to move it over one more time. And when you move it to the left, your exponent is going to increase from 8 to 9, and that's how you get 1.44, which is an acceptable number because it's between 1 and 10, times 10, and we moved it one more time, so 8 became to the 9th power. The last step, moving the decimal one more time, is a part that gets people messed up, so make sure you're paying attention to the next one if we have to do that. 3.0 times 10 to the negative 4th to the 3rd. Okay, remember for this one, just like the bell work, you have to distribute the 3rd power to both things. So 3 to the 3rd and 10 to the negative 4th to the 3rd. Now we're raising a power to a power, unlike the last ones. Now we're multiplying. So 10 to the negative 4th to the 3rd will become 10 to the negative 12th. So 3 to the 3rd is 3 times itself 3 times. 3 times 3 is 9, times 3 is 27, times 10 to the negative 12. And 27 is an unacceptable number because it's not between 1 and 10. So if your decimal is here for 27, you have to move it over one more time to make it 2.7. Move it over 2.7. And notice it was negative 12. We moved it to the left. It became bigger. Negative 11 is a bigger number or a larger number than negative 12. Remember, it's like on a scale. Goes this way. As you're counting up from 0, your numbers get bigger, 1, 2, 3, so on and so forth. But as you're counting down from 0, negative 1 is larger than negative 2, which is larger than negative 3. So that's how negative 11 is actually a larger number than negative 12. So when you move 27 to 2.7, you made it larger and become times 10 to the negative 11. C says 5.4 times 10 to the negative 2 divided by, and it actually wrote them side by side. Notice it's easier if you stack them on top of each other like this. 5.4 times 10 to the negative 2 over 7.2 times 10 to the negative 8. So divide 5.4 by 7.2 and 10 to the negative second, divide that by 10 to the negative 8. Remember, we're dividing the same basis so you can subtract them. So what you're left with is 10 to the negative 2 minus negative 8. Notice the minus the negative part right there. Minus a negative means plus a positive, and that's how we wound up with 10 to the 6th power. 5.4 divided by 7.2 is 0.075. This is, and then times 10 to the 6th power. This is not an acceptable number, 0.75, because it's not between 1 and 10. So we have to move that decimal one more time. Notice we moved it to the right this time. So 7.5 times 10, r to the 6th power is going to go down 1 and become 10 to the 5th power. 7.5. If we moved it to the left, and it works backwards from when you're doing it the other way. If we move it to the left, it gets larger, like the last one went from the negative 12 to the negative 11. This one, it moves to the right. It goes from 6 to 5. It gets smaller. And then you have a few two problems on your checkpoint. You can do your bases together. 2.5 times 4.1. It says you do it without a calculator, so 2.5 times 4.1. We can do that without a calculator. 1 times 5 is 5. 1 times 2 is 2, which is placeholder. 4 times 5 is 20. 4 times 2 is 8. Plus 2 is 10. So when we add those up, we get 1,025, but we have to move 2 decimal places since we had once, twice here. So we wind up with the number 10.25. Again, that's without using a calculator. And we have the same bases we're multiplying, 10 to the 4th times 10 to the 6th. So you multiply those same bases. That means add the exponents, 10 to the 4 plus 6. And you wind up with the number 10.25 times 10 to the 10th power, but 10.25 is not an acceptable number. It's greater than 10. So you want to move that decimal one more time over. Move it over one more time, and you get the number 1.025 times 10. Notice we moved it to the left, so the number 10 to the 10th power became larger, became 10 to the 11th power. So in scientific notation, 1.025 times 10 to the 11th, or 102,500,000,000 when you move it 11 times. The next one, 2.4, notice that it says divided by 9.6. So it's easier to stack these on top of each other. 9.6 times 10 to the negative 7th, you have the same basis. This is going to give you 1 over 4 because the number 2.4 goes into both. And it's going to be times 10 to the negative 4 minus a negative 7. Minus a negative means plus again, like the one from a minute ago. So 1/4 is the same thing as 0.25 times 10 to the positive third. But 0.25 is not an acceptable number. You got to move it one more time. It becomes 2.5 times 10. And since we moved it to the right one more time, it becomes 10 to the second, which is 250.